So in this question, we're looking at applications of differentiation, and it is a section B question, meaning we're going to be pulling on different areas of the course to solve the problem. So they tell us that this is the weekly revenue produced by a company manufacturing air conditioning units, and they're telling us it's seasonal. The revenue in euro can be approximated by this function, which is RT 22,500 by cos pi over 26t plus 37,500. So it looks really complicated from the onset, but it's really straightforward differentiation and really straightforward functions. The numbers and the symbols just look a little bit awkward. So if we look at the first part here, it says find the approximate revenue produced 20 weeks after the beginning of July. Now here they tell us that T is the weeks, or the number of weeks measured from the beginning of July. So what we now know is we actually have a value for our T here. So T is the number of weeks measured from the beginning of July. They're now saying what would happen if we had 20 weeks. So all we have to do here is, instead of our T now, we actually have R of 20. So I'm going to put in R of 20 is equal to 22500 cos pi over 26 by 20. So that was our 20 coming from the question for part A. And then that's going to be plus 37500. And then all we do is we're going to tidy that up as much as possible. So we've got 22500, and now it becomes cos of 20 pi all over 26 plus 37500. And if we put that all into our calculator and we make sure that it's in radians, that's a really big mistake that could be made here. Make sure it's in radians. When we put it into our calculator in the correct format, we get 20658.51, and that then the unit is euros. In part B, we are asked to find the two values of the time T within the first 52 weeks when the revenue is approximately 26,250. So something to take into account here is what they're telling us. They're telling us that we're looking within the first 52 weeks. That just means that our answer T should not be above 52, right? Because T is the time in weeks. So again, what our function was RT is equal to 22,500 times cos, and then it was pi t over 26, and then it was plus 37500. Now what we know is that we actually know what that works out to be. So when we have a time t, our answer in this scenario is going to be equal to 26,250. So we actually know what the revenue is. We know what the letter R represents. So I'm going to fill that in. And just to show us where that came from, it comes from here. Now what we need to do is we need to solve this. So what I'm going to do is I'm going to move things around. I'm going to subtract that from both sides. So then I would be left with minus 11250 is equal to 22500 times cos of pi over 26t, like so. Divide then both sides by 22500. So this is just algebra skills. If you're not sure what I'm doing, you need to review your algebra skills. So I'm dividing both sides by that to be left with cos of pi over 26t. That works out to be a nice enough number. It's going to be minus a half is equal to pi over 26t. Now we're at a stage that gets a little bit trickier, right? So far it was all straightforward. But if you look at what the question asked us for, it asked us to find two values for which we have a time t when the revenue is that. Now we would expect there to be multiple times if we're going through and beyond 1 year, because it's a periodic function. It's going to be cyclic. It's going to repeat itself several times over the years. But we're looking within the first 52 weeks, and you might be familiar, 52 weeks is a year. So we're looking for within that first cycle. Now, this is important because it's connecting the idea of trigonometry back into the functions. They're all being connected here. So I'm looking for a value for an angle. That's really all this is. It looks really complicated, pi over 26t, but at the end of the day, it's just an angle. So some angle that gives us a value for cos of minus a half. And actually, what you might remember is that there's two places where you might have cos of minus a half. We might have over here in this quadrant, and down here in this quadrant, because I'm using the cast circle. So we'd have all is positive here, only sine is positive here, only tan is positive here, and only cos is positive here. So the places where we'll have negative cos are here and here. Now what we can do first is get a reference angle here and here. So that's going to come from cos of our reference angle A is equal to, now the minus just tells us what quadrant it's in. The half is going to tell us what value the reference angle is. And if we get cos inverse of a half, then what we get out of that is going to be pi over 3. So that works out to be pi over 3 in there. And that works out to be pi over 3 in there. Now that's only a reference angle. So remember, we still have to figure out what the actual angle is that gives a negative half. Meaning, if we were here and we swung right the way around to over here at that point. So if we rotated around, what sort of rotation would I have to do? So what we do is we use the fact that, well, if it went the full way to this line across here, it would have done pi radians, but we've stopped short of that. We haven't gone the full way around. We've stopped short of it by pi over 3. So if you look at that, we've stopped short of it by pi over 3. So really that purple angle, we'll call it theta, is equal to, that's going to be pi minus the pi over 3 minus the reference angle. And what we will get is 2 pi over 3. The other one then that we need to figure out is going to be all the way around here. And that would be, if we were to swing around and get to pi, we actually go past it by pi over 3. So let's look at that rotation again. If we're here and we rotated around to here, we'd be at pi, but we have gone past that angle by pi over 3. So what I'm looking for is when we have theta is equal to pi plus pi over 3. So we're going to have 4 pi over 3 for this one. So those are the two values for the angle that would give us minus a half. Now the angle wasn't just theta. So if we look back at what the angle actually was, the angle was pi over 26t. So it wasn't theta, it was pi over 26t. Now I can deal with that. So what we have at the moment is we have that theta is equal to 2 pi over 3. But we know theta was that guy. So it's actually pi over 26t is equal to 2 pi over 3. And then what we would need to do is divide both sides by pi. And we're left with 1 over 26t is equal to 2/3. So in this scenario, what we're going to get is multiply up by 26 on both sides, and we're going to have 52 over 3 is what we would get for this one. So 52 over 3 weeks for one of the times that it's going to equal to that. And there's another time when it's going to equal the same value. So it's cyclic, just remember that. We're talking about cyclic values, meaning they're going to repeat and be periodic. So that's important to consider there. The other one that we had, that we said theta was equal to, where we had the negative a half, was down here. So we also had that theta is equal to 4 pi over 3, but we know that theta, remember, is pi over 26. So we have pi over 26t is equal to 4 pi over 3. Divide both sides by pi, multiply up by 26, and we're going to get 104 over 3 weeks. And there's the two values. So we really needed to pull on our knowledge of trigonometry to solve that problem. Right, so for part C, we're being asked to find the first derivative of the function. Now it looks really horrible and really complicated, but break it down into what it is. This is a constant. It's got no variables. If it's a constant, we know when we differentiate it, it's going to go. It's going to go to 0. The other thing we have is cos, and what we know about cos is it goes to minus sine. The only difference is we've got pi over 26t inside here. So that comes into play just by the chain rule. So let's take a look. If I differentiate that, I'm still going to have the 22,500 because that's multiplied by the cos, and that'll stay the same throughout. And if you're not sure why, try use the product rule on it and see what happens. You'll find that every time you've got the constant or the value here, 22,500 for example, multiplied by your cos, that will stay throughout no matter what happens. And then we have cos of pi over 26t. Now remember, cos goes to minus sine, and we keep the pi over 26t the same. That part does not change. So I'm differentiating this. The cos part went to sine here, or rather minus sine, really important. And we then have that is going to be the differential of the cos. Now we have to multiply by the differential of what was in the bracket because we haven't actually dealt with that. So now I'm going to multiply by the differential of pi over 26t. So that's going to be just pi over 26. So the same way as any other value. So for example, if it was 2t, we'd know that that goes to 2. If it was 3t, we'd know it goes to 3, and so on. So we're just using the fact that when you differentiate anything to the power of 1, so t to the power of 1 in this case, you just take the number in front of it, the coefficient there. So you've got pi over 26. And then I'm just going to multiply all of that out. So I'm going to have minus 22500 sine by pi over 26t. And that's all then multiplied by pi over 26. So I could write it out further as minus 22500 all over 26 multiplied by pi, and then my sine pi over 26t, like that. And I'm then going to divide. I can simplify that. I can divide them, and I'm going to get minus 11250 all over 13 pi sine of pi over 26t. So for the next part of this question, we're asked to look at showing how something is increasing 30 weeks after the beginning of July. So if something is increasing, it has a positive slope. So the rate of change is positive. That's another way of thinking it. The rate of change is positive. So a positive rate of change and positive slope. How do we measure rate of change? Rate of change is the first derivative. That is the differential of revenue with respect to time. And what we know is that if something has a positive rate of change at a particular point, because remember, we're dealing with the periodic function here, that's obviously going to have different rates of change depending on what aspect or area of the graph we're looking at. So that's going to be different at every single point on that graph there. So we're looking for a very particular point, and we're looking for when our t is 30. So all we have to do is use the differential in the last part, and we're going to fill in are 30. So we've got 13 pi sine, and then it's going to be by pi over 26 by 30. And what we will get if we put all of that into our calculators is we're going to get 402.164 pi, which is going to be equivalent to 1263.44. That value is not negative, it's greater than 0. If it's greater than 0, it's a positive. And if it's a positive rate of change at that particular point, then it is increasing, which is what they wanted us to show here. So the last part here, part E, says find the values of time t within the first 52 weeks when the revenue is at a minimum. That is a key word that you should associate with the process. So the process that we should have in our heads is that when we're at a minimum, we need to differentiate, and that differential, the first derivative, is equal to 0. Okay, so we need to go back up, and I need to get what the derivative was. So this was it. And what I know now is we're at a minimum, and when we're at a minimum, the differential is going to be equal to 0. So here we have it. And I'm going to let it equal to 0 because they've just told us it's a minimum. So you need to have kind of keywords and then triggers in your head. Minimum differential equals 0. Maximum differential equals 0. Now we will have to do a little bit more than that, but because it tells us to verify our answer using the second derivative. But let's just figure this one out first. So again, we're going to have to solve this, right? Which looks really complicated on the surface, but it's really, really not. First thing I would do is I would multiply everything through by 13. When I do that, I'm left with minus 11,250 pi sine pi over 26t is equal to 0. I'm going to divide everything by minus 11250 pi. Let's do two things this time. If I divide 0 by that, I'm left with 0. So I've got sine of pi over 26t is equal to 0. So I'm then looking for the values within the first 52 weeks where we have a value of 0 for sine. Now that is going to need our circle as well, right? So we're thinking about cyclic values, periodic functions. So we need to think about our unit circle. So when is sine 0? As sine is connected to the y value, sine is 0 at 2 points. It's at 0. So when we have our time is 0, or if we were to go the whole way around to the other side here, we would also have 0. Now that is going to be our value of pi. So what we need to do then is the angle as a whole, rather than t, apologies. So the angle as a whole is going to be equal to 0. So what I'm going to have is that pi over 26t is equal to 0, or pi over 26t is equal to pi. And then what I'm going to do is I'm going to multiply up by 26, and I'm going to get pi t is equal to 0. T is equal to 0 when I divide across. The other value I have then is going to be divide both sides by pi first, and then I'm going to be left with t all over 26 is equal to 1. Pi divided by pi becomes 1. That then means that time multiply up by 26 is going to be equal to 26. So now I've got two values which we should expect. Okay, so we should expect that there would be a maximum and a minimum within our cosine function there. Now, if you remember back to your cosine graphs, we would expect that graph to have a maximum at 0, because remember, the cosine graph goes through 1. If it's just cos x, it'll go through 1, and it'll peak there. So that's what we need to be thinking about as well, connecting all of these ideas, especially in section B of the paper. So now we need to confirm that the one that we think it is a minimum. So I would predict that the 26 weeks is the minimum, because we know that cos usually should start with the maximum. So what we can do is get the second derivative. Now, that's going to take a bit of effort. So we need to go back and get what was our first derivative, and we're going to go again with that. So I'm going to bring that down here. I'm going to give us more space, so I'm going to move this guy underneath. So if I differentiate that again, I'm going to use the chain rule again. So I'm going to have minus 11250 pi over 13. It's going to be minus. Sign goes to cos, positive cos, so I don't need to mess around with the signs. I don't change the angle, but I do multiply by the differential of what was in the bracket. So that brings me to, when I differentiate that for the second time, I'm going to get minus 11250 pi squared, and then I'm going to have 13 by 26 on the bottom here, cos pi all over 26t. Now, what I need to do is figure out which one gives me the maximum and which one gives me the minimum. So at this stage here, you can of course multiply all of that out first before filling it in, but when I fill in the values, I'm just going to do it really quickly. Here, pi squared all over 13 by 26, cos pi over 26 by 26. When I get that, I'm going to get a value of 328.5001465, and that value is greater than 0. And you'll remember that whenever we get a second derivative that is greater than 0, we are at a minimum value.